From the very beginning of human history, people looked at the endless oceans and the vast skies with curiosity and wonder. The sea represented mystery, while the sky symbolized freedom. For centuries, humans dreamed of creating a machine that could conquer both. The idea of an aircraft flying high in the air and then floating smoothly on the sea once seemed impossible, almost like a fantasy. But with the power of science, engineering, and human imagination, that dream became reality. Today, there are aircraft that can not only travel through the clouds at incredible speeds, but can also land and float on water like giant boats. This achievement is considered one of the greatest examples of human intelligence and technological progress. The ability of an aircraft to float on the sea is based on an important scientific principle called buoyancy. Buoyancy is the upward force exerted by water that allows an object to stay afloat instead of sinking. Engineers studied this principle carefully while designing seaplanes and water-landing aircraft. When an aircraft lands on the ocean, its lower structure is specially designed to spread its weight evenly across the water surface. This prevents it from sinking and helps it remain balanced. Some aircraft are equipped with large floating structures called pontoons, while others are built with boat-shaped bodies that naturally float on water. These designs allow the aircraft to move smoothly across the sea after landing, just like a ship gliding over calm waves. Creating such aircraft requires years of research, testing, and advanced engineering. The manufacturing process begins with designing a structure that is both lightweight and extremely strong. Ordinary steel is too heavy for aircraft construction, so engineers use special materials like aluminum alloys, titanium, and carbon fiber compounds. These materials provide strength without adding unnecessary weight. Since seawater contains salt that can damage metal through corrosion, aircraft designed for sea operations are coated with special anti-corrosion layers. These protective coatings help the aircraft survive harsh marine environments for many years. One of the most challenging parts of building a sea aircraft is designing the landing system. Landing on water is completely different from landing on a runway. Water surfaces are constantly moving because of waves, currents, and wind. A pilot must carefully control the speed and angle of the aircraft during landing to avoid a crash. Engineers create reinforced lower hulls capable of absorbing the impact of touching water at high speed. Every curve and angle of the aircraft body is calculated with precision to ensure stability and safety. If the design is even slightly incorrect, the aircraft may flip, sink, or suffer severe damage during landing. The engines of sea aircraft also require special protection. Aircraft engines are extremely sensitive to water, especially salty seawater. If water enters the engine system, it can cause complete engine failure. To prevent this, engines are usually mounted higher above the wings or protected with specially designed air intake systems. Engineers also create waterproof electrical systems to protect the aircraft during heavy rain or ocean spray. These safety features allow the aircraft to operate in difficult weather conditions and rough sea environments. Another remarkable invention connected to aircraft and the sea is the aircraft carrier. An aircraft carrier is essentially a floating airport built on a massive warship. These giant vessels carry fighter jets, helicopters, and military aircraft across oceans. Aircraft take off and land directly on the moving ship, even in the middle of the sea. The construction of an aircraft carrier is one of the most advanced engineering achievements in the world. Its enormous body is designed to distribute weight evenly across the water, allowing it to float despite carrying thousands of tons of equipment, fuel, and machinery. Inside an aircraft carrier are hundreds of compartments and steel sections, carefully arranged to maintain balance and stability. Even if one section is damaged or flooded with water, the ship can continue floating because the remaining compartments provide support. This advanced safety system was developed after maritime disasters taught engineers the importance of compartmentalized design. Modern aircraft carriers also use powerful radar systems, navigation technology, and automated controls that help aircraft land safely, even during storms or rough seas. The wings of an aircraft play a critical role in both flight and sea operations. Wings create lift by pushing air downward, allowing the aircraft to rise into the sky. However, sea aircraft require specially strengthened wings that can handle additional pressure during water landings. Engineers spend years testing wing designs inside wind tunnels and computer simulations before final production. Every small detail matters, because even a tiny imbalance can affect the aircraft's performance and safety. Modern technology has made sea aircraft more advanced than ever before. Today's aircraft use computerized navigation systems, satellite communication, and artificial intelligence. To improve safety and performance, Some aircraft contain sensors that measure wave height, wind speed, and ocean movement in real time. This information helps pilots make smoother and safer landings on water. Many modern aircraft are also equipped with emergency flotation systems that automatically activate if the aircraft experiences trouble during flight. These systems can keep the aircraft floating long enough for passengers and crew to be rescued. Sea aircraft are not only used for military purposes or luxury travel, they are also extremely important in rescue operations and humanitarian missions. When ships are stranded in remote oceans or natural disasters strike coastal areas, seaplanes can quickly land on water and deliver emergency aid. In regions where islands lack airports, these aircraft provide transportation, medical supplies, and communication. They connect isolated communities with the rest of the world and save countless lives during emergencies. Looking deeply into this achievement, the story of aircraft floating on the sea is more than just engineering. It is the story of human determination and imagination. Humans refused to accept limitations. They transformed impossible dreams into reality through knowledge, hard work, and innovation. Every aircraft that lands on the ocean represents years of dedication by scientists, engineers, mechanics, and designers who worked together to challenge the boundaries of what machines can do. When people watch a massive aircraft descend from the sky and gently float across the sea, they witness more than technology. They witness the power of human creativity. It is proof that with intelligence and persistence, humanity can master both the skies above and the oceans below.